Seeking English, S.A.T. Workbook, page 366, problem 3, one of my favorites. You'll see why. It says, in the system of inequalities above, if the system of inequalities above is graphed in the xy plane above, which quadrant would contain no solutions to the system? And the answers are bulky, so I haven't written them. It's quadrant 1 is A, quadrant 2 is B, quadrant 3 is C, and there is no solution in every quadrant. Sorry, there is a solution in every quadrant is D. Again, A, quadrant 1, B, quadrant 2, C, quadrant 3, D, there is a solution in every quadrant. Okay, now on the real test, they might not be as nice to you as somebody was to you here, putting the inequalities in this order, and you're going to see what I'm talking about. What I need to stress with this system of inequalities is that it's not or, it's and. A solution needs to match both inequalities. It can't be one or the other. It has to be a solution for both things. That means if you draw an area on the grid, on the graph, and it covers a certain area, that area is only going to become smaller when you apply the second inequality. Okay, it doesn't expand the available area of solutions. It reduces the available area of solutions. This matters a lot on this problem, and it could matter a lot on a similar or related problem. So let's take a look. Two things you need to know about these areas. One is they're limited or bounded by a line. There's a line that defines the edge of this area, and the area includes that line. It's not going to matter very much here. But the first thing you want to do is figure out where's that line. Before you figure out what's above, below, left, right of that line, figure out approximately where the line is in terms of these quadrants. I always start with the intercept point, okay? Because if the slope doesn't tell you where to draw the line, it just tells you what the line is shaped like. Where to draw the line is the first question. What does it intersect? So here we have a -1. This is slope-intercept form. Y equals mx plus b. So that's plus b is -1, approximately there. Doesn't matter that much. This is a conceptual thing. There's no calculation. Okay, that's intercept. Second thing is the slope. It's a negative slope, and it's a steep slope. But what you need to know is that it's a negative slope. So it goes. Wow, that could be a straighter line. Wow. Take two. No take two. There. That's what we have. Okay? So that's our line. It's the first thing we know from the first line. Is that. Now, it's the intercept and approximately the slope. But it's not equals. It's equal or less than. So and it's the y that we're gonna consider. Y is this value, not that value. So we need to consider this value. There are going to be solutions either above the line or below the line. What this less than tells you is that the solution may be on the line or it may be less. If it's less in y space, then it's going to be down from there. So that, okay, solution there, and a solution there. So I see solutions in quadrant 2, quadrant 3, and in quadrant 4. I don't see solutions in quadrant 1. Okay? Before we go any further, please, let's look at the possible answers. Which quadrant would contain no solutions? Quadrant 1, yeah, that matches the description. Quadrant 2, no, it says there's solutions there. Quadrant 3, solutions there, and quadrant 4, solutions there. So, slow down. Don't even look at the second equation yet. Okay, is there anything that we could do to this space that would change the answer? Right now, quadrant 1 is excluded. Okay? The other answers do not allow for the exclusion of quadrant 1 at all. Okay? Letter B assumes that there's a solution in quadrant 1. Letter B assumes that there's some kind of solution in quadrant 1. Letter D assumes there's some kind of solution in quadrant 1. So, and unless you misread this problem and think that the second inequality is going to expand this space in quadrant 1, then you don't need the second equation. Okay? Okay? Again, If you get to this point on a similar problem, don't go any further with it. You have the answer, okay? They've given you some extraneous information to wear you down, confuse you, and waste your time, but don't do it. Don't do it. You've excluded quadrant 1. There's nothing else to do, okay? But contrary to what I just said, I'm going to show you how useless it is to go on to the next step. Okay. Here, intercept is going to be positive 1. Again, positive intercept. And the slope is 1/2, so it's a kind of a, it's going to be perpendicular to that one. So I'm just going to draw like that. I'm going to draw badly, like I drew the other ones. Here we go. Okay, and so it says, again, less than. So there's a solution in quadrant 1. There's a solution, some kind of a solution in quadrant 2. Solution in quadrant 3, and this has quadrant 4 because it's all the way below. So this one has solutions in all 4 quadrants, but again, the second inequality does not provide you any useful information. If you looked at it first, you could be mistaken and think the answer is D. There's a solution at every quadrant. Then you would need to look back at the first one and say, wait a minute. But the second one excludes quadrant 1. Okay, so again, on the real test, I don't know if they give you a useful inequality and a useless inequality and make you play with them both like this on the graph. I don't know in which order they're going to do that. So the problem could work like this, or it could work the other way like that. The answer would be the same. It might just take you longer to get to it. And the order in which they give you these things helps test designers fine-tune tests. So that would explain why they needed it to be a little bit easier this time or a little harder the next time. I don't know. If you're confused by anything that I've said so far in this video, and you might be, it is a little bit confusing. Don't hesitate to tell me in the comments section. If you disagree with my answer, great. You're going to be wrong, but that's okay. We'll talk about it. Tell me in the comments section, and we'll go over it. Thank you.